Homogeneity is like the word homogeneous. What's that? It's the same. Good. So what we're doing when we do the chi-square test is we're testing more than one group to see if they're the same. Okay? So you have, so it says when do we use this test? It's when we have one variable and two or more, so I'll just say multiple samples. And we're just testing to see if they're similar or they have the same distribution. So what do you think the null hypothesis is? Yeah. Okay, so the null hypothesis, just the distributions are the same. Obviously, you're going to put the same context, as always. And then the alternative is that they're not the same, they're different. Yes, it's always a null. It's that they're the same. Alternative that they're different. Which makes sense. So we did alternative and null hypothesis and symbols. If they were different, then you're saying that one of them was greater or less than the other one, or several were greater than or less than. Questions so far? It's easy. Okay, I don't even really know why I'm writing this down, but I am. The test statistic is still chi-squared, and you still calculate it the same way. If you want to calculate by hand, it's the observed value minus the expected value squared divided by the expected. Oh, and I forgot something. Oh, what's that? Yeah, well, you know what that means. It's got an extra curve. You will need to find the degrees of freedom. How did we find the degrees of freedom yesterday? Some of you were just doing this, so you should know.
Categories minus 1.
Number of categories minus 1. This one's going to be a little different. There's more than one category. So it's the number of rows minus 1 times the number of columns. That's complicated?
I don't like that.
Oh, sorry. Just multiplication and subtraction. Maybe when you find your calculator, you'll be able to handle it.
What did you write on the second one? Rows?
Rows,
Columns.
columns,
Rows and columns.
Oh, calls.
rows and columns. I'm tired of writing things out. Is that not an appropriate abbreviation?
Well, it kind of looks like a car.
Yeah. We're being fine fast. Okay, in your calculator, it's yesterday we did chi-square. It was called goodness of fit test, so GOF. Today we're going to do chi-square test, not GOF, just chi-square test in the calculator. Is what it's called. So, ready for a couple of examples? Yes. What? Yeah, really two. The ones on the back go together. Okay, so the first example, you have 1,058 students in different years, 1980, 1990, and 2000. So hopefully these are 3 different samples. They're asking them their post-graduation plans. So we're hoping that the seniors in 1980 are not the same people as the seniors in 1990 and the seniors in 2000. And they're seeing what they did. So we're seeing, is there an evidence of a change in their choices for the figures? Okay, so I'm going to come back to A. That's the most complicated part. let's find first the hypotheses. So what do you think the null is in context?
Situation is
Isn't evidence on changing interest in high school?
Well, those sort of evidence, that's what we're going to try to prove. So,
It is now.
there is no change.
okay, so no change, or they're the same. No change in choices, I guess, for high school grads. And then, so the alternative would be, or could be, that there is a change. Okay, here's our complicated calculation. The degrees of freedom. So, degrees of freedom. How many, okay, don't count the total. That's just totals. So, how many rows do we have? 4. So, 4 minus 1 is? 3. And help out those people who think this is complicated. How many columns do we have? 3. 3 minus 1 is 2. So, our degrees of freedom is 6. That was hard. You did well, though.
Leave out the totals.
Yeah, don't count the totals as rows and columns, because they're not really variables, it's just totaling them up. So there's 4 rows. This isn't new information, it's just putting all that.
Rows go this way, right?
Rows to that. It doesn't matter which one you call rows and which one you call
You count one.
Yeah.
Row.
Well, yeah. 1, 2, 3, 4 rows. 4 minus 1, 3. 1, 2, 3 columns. Don't count this. Count the one that actually has data. Those are just headings.
I wonder what's doing my job.
What? I don't know. I guess some of the graduates, if anyone in this category, they're not going to go to college or get a job. They're just going to travel after.
That'd be a place to go.
It'll be great.
It's
Just travel.
It'd be nice. Would be nice.
Apparently in 1980 that was somewhat a popular thing. Travel.
Why not?
By walking. Start to go. Not in today's world. People don't Okay, we're going to go back to A now. I'm going to show you how to do this, and then I'll show you the shortcut. But pay attention, I'll make it fast. So it says calculate the expected value for each cell. So that means, okay, the expected value means if this is true and that there's no change, what would we expect the numbers to be? That doesn't mean they'll be exactly the same, because look at the sample sizes. Are they the same? So it would be weird if they all had 100, because this one had a 453, and then the next one had 290 in the sample. So we want their proportions or percents to be the same, right? If it's the same for each year. So the way you do that is you take the total for each category. So there were 853 total students that decided or said they're going to go to college after graduating. Out of 1,058 total students. That makes sense? Okay, someone calculate that for me. You would, but yeah. I know it's 0.8 something.
I got 8-1, 8-06 or something.
Okay, we'll say 0.81. So that means that 81% of all the students in these 3 samples say they're going to go to college. Well, if all 3 samples are the same, then 80% of the students from 1980 would be going to college, 80% from 1990 would go to college, and 80% times 2,000. So how did you figure out what 80% of the students from 1980 is?
Multiply by 14.
Yeah, you just take 453, it's 81 times 453. I didn't bring my calculator. Oh, it's right here. I'll save that for later. So it's, what's 81% of 453?
365.
365. And this is how, even if you do the shortcut that I'm about to show you, this is how you write your expected value. You put it in the same, these are called cells. So you could do the same thing for 1990. 81% of the students from 1990, if they were going to college, if they were going to college, there were 290 students in 1990, so 81% of 290.
234.
234. Oh, that's a 2. Can you calculate that for 2000? No? Yeah, I gotta try.
254.
What are we doing right now?
Okay, that's good to understand, and I know you're not the only one that doesn't get it. So I'll go back. We're saying if this is true, and that for all 3 years, their choices are the same for all 3 years, then there would have been 365 students in 1980 that are going to college, 234 in 1990 that are going to college, and 254 in 2000. They're called the expected values. We're saying if this is true, this is what we would expect the numbers to be. And so these other numbers are called the observed values.
So you just take the total divided by the.
Yeah, that's how you do it by hand, but I'm about to show you how to use the calculator. I'm just showing you where these numbers come from.
I don't know if this is actually a big problem,
Okay.
but my calculator, just because it's been messing up with those.
Yeah.
In my calculator, I'm like one number away. Like, yeah, because
367, 235.
I don't think you rounded, because I got 255.
Okay,
I think
then
you use
never
the actual limiting decimal.
Okay. If you didn't round the decimal, you used like 0.806, something.
Like, even mine don't round in those numbers, so it's to know.
Wait, when you're doing it, are you doing a total or just what is in that row, the college row?
Which part?
Like 0.81, it'd be times 288, right? Or are you doing
No,
the bottom?
times this. 0.81 times this.
Okay. That's fine.
Okay, so if you were going to do the same thing for employment, you would do 139 divided by 1,058. Don't do it. But that would give you the percent that are planning on getting a job. And then you'd multiply that percent times the totals. Does that make sense? You get a percent and then multiply it times the totals. Get a percent, multiply times the totals. Okay? And like I said, I want you to see where the numbers came from. They're not just thrown out there. But the calculator will do that for you, which makes it a little faster because that's 12 calculations. I guess it's not too bad, but we can save it. So I'll show you how. You have to actually do the test first. So we're going to find the chi-squared and the p-value. How many people learned how to do matrices in Algebra 2 or some other class? Do you remember matrices? Okay, well you get a little refresher. That's why I have my calculators get complete. So the first thing you have to do is you're going to put the observed values, which is the original numbers in the table, into matrix A. This didn't have any words. You might try this if you don't remember.
So do we need to do 4 by 3?
Okay, so the matrix is right underneath math. Do you see that? So you go second, x to the negative 1. Yours probably says different things because I've already used mine today. Go over to edit because we're typing in a matrix. Okay, and then the first thing, this is called the dimensions. It is the rows and then the columns, which we already talked about when we did the degrees of freedom. So how many rows do we have? 4, and we have 3 columns. If you put those in, if you put the wrong numbers in, it's not a big deal. You'll notice when you start typing in everything that you don't have enough rows or you don't have enough columns. And you can change it. I'm not going to see that from here. Now you just type all the numbers in. 3.
Expected or the normal?
They're called the observed, the originals. Can you see this? 98, does it say 98? 24 and 17. What's the third military group say?
18, 19, 55.
Thank you. And 72 and 5? No, you don't know how to do matrices. I don't know how to help you either.
Miss Hendricks, isn't it supposed to be 288?
I don't know, I
Three or an
can't.
eight?
Yes, I said I couldn't see it.
Okay.
That would cause problems.
It's kind of close.
Kind of not at all close. Okay, so the next step, does anyone have trouble besides Cameron? Leave this in. We'll have to figure it out. Okay, now we're just going to do the test. Go to stat, test, and look for chi-squared, not GF, just chi-squared. There this is. Yes. Oh, there it is.
Oh, do we need to create another
Nope,
matrix?
nope. This is why, where the calculator will help you a lot. Okay, so you go to chi-square test. See, it says observed in A, which is what we did. It says expected in B. We didn't type anything into B, but it will automatically calculate them for you, which is great. And save them as B. So just go to calculate.
That's pretty neat.
Yeah.
Cool.
So why do we don't even have to do that, do we?
No, I just like let me press on this.
Thank God.
So let's go ahead and write down the chi-squared is what? Oh, it's right there. 72.8. With 77. And the p-value is 1.1.
Zero.
What?
Zero.
Yeah. Times 10 to the negative 13. I caught myself. So that's not right.
Do you not have to?
You can just put 0
Right
here.
here. You know that I was a boost.
I won't make you. You probably should, but
On a test, will we?
probably. It's always probably a good idea to write down the formula.
So, on the test, would we just calculate the first two on our
Well,
hand?
I'm going to show you in just a second. So after you do this, it's kind of the backwards order, but since we're using the calculator, that's okay. We're going to go back and get all the expected values because you do need to show those. So we're going to go back and look at matrix B. Very sharp marker. So go back to matrix second x to the negative 1. And if yours didn't have anything in matrix B before, or it has something different, it should have changed. Just go down to B. Don't go to edit, just change B and hit enter. And those are all the expected values. You guys are really excited. So 360, 365, 234, and hopefully that one was 254. So go back and write those in. And you do need to do that with your homework.
Would it not be easier to go into edit so you can see all of them on the back?
Does it make look different?
Then rather than doing that.
Okay, whatever. That's fine.
Do you want us to run?
Yeah,
Oh, I
just
see what you're
mainly
saying.
go
Yeah,
for
makes
some
it smaller,
space if you
easier
don't.
to read. So on the AP test, they'll want us to fill it in,
Well,
maybe.
if, yes, if this was a free response, we definitely want to do that. And the reason is, it's one of the conditions, I just haven't talked about it yet. One of the conditions is that the expected values have to be bigger than 5. And that's how you show it. You just write them all down and we'll see, like this one, they're all bigger than 5. So it's
So by us doing that, that'll make sense.
Yes. So calculate the expected values, that's standard to do it just like that, with a slash and then,
Oh, with the slash.
well, it's like, it's happy Excel.
Okay. Can we do a horizontal slash?
Sure. I
Made a mistake.
You can fill out questions. Yes, you can do horizontal. Now we're pretty much finished. What's our conclusion? Would we reject or fail to reject?
Reject.
Reject the null hypothesis, and there is evidence of a change. Now, what if it just said, like, since it says there's evidence of a change, how has it changed? Could you just look at the table and tell me how things have changed through the 3 years?
More people are talking
More people going to college, less traveling, less going into the military. That's
What would have happened to those black people?
Let's see.
more per
Let's
percentage
do-
wise. Because it was above what we expected.
254s.
No, 288. This is how many are actually going to college. If it hadn't changed, only 284. Any other questions? That was just extra. Okay, turn the page. Let's see how fast we can finish this.
Another test.
Yeah, but now you know how to do it. We can do it quickly. So A says calculate the expected values. You can read this. It has two professors in the grades, A, B, C, D, and F, and how many of each. And they're trying to decide if one professor is an easier grade, which is kind of dumb because there should be smarter people in one class than the other. But that's so what is our null hypothesis?
There's no change.
They're basically the same, or you can just say the grade distribution is the same. And so the alternative is that the grade distributions are different. Would that say the grade distributions are different? Is that the same thing as saying that one of them's an easier grader? Kind of. Yeah. If the grade distributions are different, saying one of them has a bigger percentage of A's and B's than the other one. How many degrees of freedom? Yeah, you're right. One of you are right. How many we have? 5 rows, so 4. 5 minus 1. We have how many columns of data? 2, so 2 minus 1 is 1. So 3 degrees of freedom.
Oh, heck yeah.
So
Okay, check the conditions. This is the first time we've checked the conditions for chi-square test, mainly because it's really easy. The conditions are on the first page of your notes if you want to look at them. The first condition, I don't really care if you write it down or not. It's just, it has to be categorical data. Is this categorical data? Are we counting how many are in each category? Yeah. We wouldn't be doing this if we weren't physically. The next 2 conditions are the ones we always check. Does this say it's a random sample? Doesn't say a whole lot of anything. No. So it's hopefully representative and unbiased sample. many students were in Professor Alpha's class?
What?
How many students did Professor Alpha have?
A lot. Over the department.
40? You think that's less than 10% of all his students? Ever? Not just 1 year.
Oh.
Yeah. So it's all Alpha students. And how many did Professor Beta have? 32, so that should be less than 10% of all his students. What?
What's first year teaching me English?
You're right, then it would be bad, but we're just gonna have to assume that's good. Here's the last condition is the main one we need to check. So yes, the last condition says, in order to have a large enough sample, we have to have at least 5 expected individuals or expected values in each case. Now, these right here, these are not the expected values. These are called the observed values. So in order to check the expected ones, we need to get a matrix in the test. So go ahead and type these into your calculator. Now, I try it. Shall we wake up? I'm doing very good today.
So whenever you do the A, and it'll just do the B for you.
Yes, it'll automatically save them in the B. Come on. So type these into matrix A. This is a what? 5 by 2 matrix. Did you figure it out?
I don't
Pass that back, we'll let her try.
actually think I can make matrices. If
I know it will, but how?
And then like after I make the matrices, I think I actually made the matrices. But like I got lost because like went on to like a different part.
Oh yeah.
What do you do with the matrices when you make them? After you
Just
make them?
nothing, then you do the test.
Do you make like a matrix? Do you make a matrix of your?
No, the calculator should save those for you in a matrix. That's what it does in ours.
But like yeah, but like does it save it? Like do you make like do you get like one for like do you get one for expected and observed?
You just do the observed, and the calculator will save the expected for you.
Oh, it doesn't.
Yeah. Once you do the test, you have to go ahead and do the test.
You just have to go through and do this.
Yeah, so go ahead and do, even though it doesn't ask us, after you get them in the calculator, go ahead and do the chi-squared test. You don't even have to look at it. And then go back to the matrix and look up matrix B.
What if it's right on top?
Just round. You can round these. So I got, I think these are right, 7, 13, I can't read what that one says. 12,
6 and 2.
6 and 2. And then 5, 10, 10, 5, 5.
We're gonna have.
So all of those are supposed to be bigger than 5, are they? No, the bottom row is not. So the last condition is not met. So all expected counts or expected values are not greater than 5. That means you don't have a large enough sample. That means your conditions are not met. So if this says, are all the conditions met? No, they're not. They're not bigger than 5. That makes sense? Sort of. Now, look at number 5. That's why I say it's really not a different example. Because this is a problem, you can't really reject or fail to reject the null hypothesis. So what they've done is just combine the last 2 rows, and instead of saying A, B, C, D, and F, you just have A, B, C, and everything below C. Now, you can't just combine rows just because, but does it make sense in this case to combine D and F? Is it logical? Sure, especially in a college class, just FYI, use it with credit for D's anyway. So A, B's, and C's, and then you have anything that you don't really get credit for. Okay, so now it says calculate the new expected values for each cell. So go back to your matrix. Is it a different size?
Yep.
now it's a 4x2. Type those in. See, now I don't have a calculator.
You want them?
Sorry.
Well, before we do that, do you want to tell me the chi-squared and the p-value? Are you guys
this
lost?
one?
Sure.
Oh,
That's a new one.
okay, the chi-squared is at 9.3,
Yeah, that's right.
and then the p-value 0.03.
Yeah, very good. And so, I know when we passed that, what are your new expected values? Go down.
7, 13, 12.
So you don't have to like delete your beings.
Alright, 10 and 7.
10 and
7.
this is, these numbers right here, that is your B matrix. You don't have to type them in, let the calculator calculate
Well,
them
what
for
if
you.
there's already like numbers in there from the last one you did?
It doesn't matter, it'll just override them. And then you have to delete them. So are now all the expected values greater than 5? So our conditions are met. Did this change the degrees of freedom? Yeah, what's the degrees of freedom now? 3, right? We have one less row, so one less degree of freedom. I like how we're really fast. Now we're done. What can we conclude? What's our conclusion? Yeah, so we are rejecting the null hypothesis.
Do we have to specify which confidence level we use? Or the
There
alpha
is,
level?
we'll just stick with 0.05 unless it says differently. Reject the null hypothesis, so there is evidence. You can either say there's evidence that there's a difference in the grade distributions, or there's evidence that one of the professors is an easier grader. And you made it, you finished.